Who is here? Yes, it's Spider-Man, one of our favorite fictional characters. I hope most of you have seen him climbing the walls of tall buildings. It seems as if gravity does not work upon him at all. Have you ever wondered how does he manage to climb the walls of tall buildings? Well, there is no magic. Rather, there is a scientific logic behind it. It is the same scientific logic that enables lizards to crawl the walls and ceilings of our houses. But what is that logic? I hope you will be able to discover the logic at the end of this video. We know air is a matter and has mass and weight. Now the gravitational force pulls the air downwards. As a result, the weight of the air creates pressure on the Earth's surface. So, the weight of air exerts pressure on Earth's surface. Now, this pressure exerted by the weight of air on the Earth's surface is called atmospheric pressure. Now look at this picture. In this picture we can see that this air column is exerting force or pressure on the Earth's surface, and this force exerted by the weight of air lying above it or above the Earth's surface is called air pressure or atmospheric pressure. So, the air all around us is exerting pressure on us. Now, this same atmospheric pressure enables lizards to crawl on the walls and ceilings of our houses. Now, the feet of these lizards have suction pads. So, as the lizards move on the walls, the air between the feet and the wall is pressed out. As a result, a low pressure is created and the outside high pressure pushes the lizards towards the wall, and due to this reason, the lizards stick to the wall. Now, this same atmospheric pressure also helps Spider-Man to climb the walls of buildings. So now do you understand why lizards and Spider-Man can climb or crawl on the walls of our buildings? So I just mentioned that the air all around us is exerting pressure on us. Then why don't we get crushed by this atmospheric pressure? Well, we don't get crushed by this atmospheric pressure because as air is exerting pressure on us, the fluid in our body is also exerting the same amount of pressure. So, the external atmospheric pressure pushes us inwards while the internal body fluids or internal body pressures acts in opposite direction, that is in outward direction. Now this equal amount of force acts in opposite direction. As a result, our body or we do not get crushed by this atmospheric pressure because the outside or external air pressure equals the internal body pressure. Unlike Earth, in space there is no atmosphere, so there is no air. But our internal body pressure is high. So this internal body pressure may cause the blood vessels to burst out. As a result, blood may spill out or come out of our body. To prevent this fatal incidents, astronauts wear specially designed space suits. These space suits are filled with air, exerts exactly an equal amount of pressure that is exerted by the fluids present in the body of these astronauts. This is how these spacesuits protect the body of astronauts and prevent them from dying. Let us now perform an experiment. Take a glass of water and a postcard. Now, cover the glass with the postcard. Then, gently place your hand over the postcard. Now, carefully flip over the glass. Now, remove your hand from the bottom of the glass. What will you observe? You will observe in an amazement that the water does not spill out of the glass. But how does this happen? This happens because the force of the gravity is less than the atmospheric pressure. That is, although the gravity pulls down the water, but the atmospheric pressure acting on the postcard is greater than that, and therefore the water remains in its place. As a matter of fact, warm air contains fewer air molecules than cold air. Also, if the temperature is high, then the motion of air molecules is more. As a result, the intermolecular spaces increases, so warm air has low air density. On the other hand, cold air has more air molecules, and also these air molecules remain concentrated in one place. So, cold air has higher air density. So, cold air being more dense exerts high pressure than warm air. This is how air pressure depends on the number and motion of air molecules. We just learned that more number of air molecules exerts higher air pressure. Now look at this air column. In this air column, we can see that more air molecules are present towards the Earth's surface, while less air molecules are present at the upper layers, that is in higher altitude. Now why this is so? This is because gravity pulls the air downwards. Therefore, more air molecules are present in the lower layers of atmosphere, while less air molecules are present in the upper layers of atmosphere, that is in higher altitudes. So, in higher altitudes, the air becomes thinner. As a result, in lower altitudes, we experience higher air pressure, while in higher altitudes where the density of air is low, we experience low air pressure. So here we see that atmospheric pressure decreases with increase in altitude. So the higher we go, the less atmospheric pressure we will experience. Now look at this graph. This graph shows fall in air pressure with increase in altitude. Now as we measure altitude with kilometer, the unit of measuring atmospheric pressure is MB, which stands for millibar. So millibar is the standard unit of measurement for atmospheric pressure. Now in this graph we can see that when the altitude is 30 kilometer, then the atmospheric pressure is less than 100 MB. When altitude falls below 20 kilometer, the atmospheric pressure is almost 100. When the altitude is lower than 10 kilometer, the atmospheric pressure is 500 MB. So here we see that as altitude falls, the atmospheric pressure rises. So this graph is negatively sloped, or in other words we can say that atmospheric pressure and altitude are inversely related. Now before we proceed with our lesson, let us try to answer this question. How is atmospheric pressure related to altitude? Positive relation, inverse relation, or independent? Well, the correct answer is inverse relation. There exists inverse relation between atmospheric pressure and altitude. That is, as altitude increases, atmospheric pressure falls. I hope most of you have lit lanterns or hot air balloons during Diwali. But have you ever wondered why do these lanterns or hot air balloons rise up? The hot air balloons rise up because hot air is lighter or less dense. When temperature of a place rises, the air in that place expands. As a result, the density of air falls because the intermolecular space increases. So this hot air rise up, creating a low pressure zone. Conversely, in cold place, the air prevailing in that place is cold. Now cold air is very denser because cold air contracts. So this cold dense air sinks, creating a high pressure zone. So we find that temperature of a place and atmospheric pressure are inversely related. That is, hot air rise up and creates low pressure, while cold air sinks and creates high pressure zone. Now here we have two weather charts that shows atmospheric conditions of two places, namely Kolkata and Jaipur. Now let's make a comparison between these two weather charts. Here we see that on 18 June 2022, Kolkata experiences an atmospheric pressure of 1004 MB, whereas the humidity is 79%. On the same day, Jaipur experiences an atmospheric pressure of 1005 MB and the humidity is 56%. So here we see that a place having high humidity experiences low atmospheric pressure, whereas a place having low humidity experiences high atmospheric pressure. Now let us explore the reason behind this. We know warm air contains less air molecules, so their moisture holding capacity is more. On the other hand, cold air contains more air molecules, so their moisture holding capacity is less. Now this warm moist air rises, creating a low pressure zone, while this cold dry air sinks, creating a high pressure zone. Thus, warm moist air exerts less pressure than cold dry air. So places of high humidity experiences low atmospheric pressure, while places of low humidity experiences high atmospheric pressure. It's a scene in the amusement park. The boys are enjoying a ride in the merry-go-round. But oops, what happens suddenly? A boy slips off the merry-go-round and falls on the ground. Now, one thing is bothering me. Why did the boy fall out of the merry-go-round and not in the merry-go-round? This is because there is a force that causes an object to move away from the center of the rotating object. And the name of this force is centrifugal force. So centrifugal force is a force that causes an object to move away from the center of a rotating body. This same force also causes ocean currents and winds to deviate or divert from their original path. Let's see how. We all know that our earth rotates from west to east. Now, if you throw a paper plane from the mid of the Indian Ocean to the north, you will expect it to land exactly in the northern states of Jammu and Kashmir. But it does not happen. What happens is that the paper plane gets deflected to the right and land in the northeastern states of India. Now, if you turn 180 degree and throw the paper plane to the south, you will expect it to land exactly straight. But again, it does not happen. The paper plane gets deflected to the left and travels towards Indonesia. But what causes the direction of paper plane to change? The direction of paper plane changes due to a deflective force, and the name of this force is Coriolis force. It is a force that changes or diverts the direction of any moving mass like winds or ocean currents, and this Coriolis force is caused due to Earth's rotation. Coriolis force is same as the centrifugal force, which causes an object to move away from the center of a rotating body. So in the previous video, we saw that the direction of paper plane changes due to Coriolis force, which is caused by Earth's rotation. Now, we saw that the paper plane deflects to the right in the northern hemisphere and to the left in the southern hemisphere. Similar to the paper plane, the winds get deflected to the right in the northern hemisphere, or in broader sense, the winds turn clockwise in northern hemisphere. On the other hand, the winds flowing in the southern hemisphere turn to the left or gets deflected to the left, and in broader view, the winds rotate anti-clockwise or turn anti-clockwise in the southern hemisphere. So, due to Coriolis force caused by Earth's rotation, the winds deflect clockwise in northern hemisphere and anti-clockwise in southern hemisphere. So, we see that the winds get diverted, and due to this diversion or deviation from their original path, the pressure condition changes. When the winds are pushed out from a region, there a low pressure zone is created, whereas a high pressure zone is created in the regions where the winds are pushed in. So, the deflection of winds changes pressure condition and leads to the creation of different pressure belts like high pressure belts and low pressure belts. We will discuss about these pressure belts in details later. So, here we see that Earth's rotation is a significant factor that affects atmospheric pressure. So, we discussed about various factors that affects atmospheric pressure. One of those factors is temperature. We saw that temperature and atmospheric pressure are inversely related. This is because if temperature rises, the density of air falls as the intermolecular spaces increases. So, warm air expands and rises, while cold air being denser sinks. So, warm air is associated with low air pressure, while cold air is associated with high pressure. So, as temperature increases, atmospheric pressure falls. Again, as warm air contains less air molecules, their moisture holding capacity is more. So, warm moist air rises, creating low pressure zone, while cold air contains more air molecules, so their moisture holding capacity is less. So cold dry air sinks, creating a high pressure zone. Thus, humidity is also a factor that affects atmospheric pressure. Another factor that affects atmospheric pressure is altitude. In lower altitudes, the density of air is more. So, in lower altitudes, we experience high atmospheric pressure. Whereas in higher altitudes, the density of air is less. So, in higher altitudes, the atmospheric pressure is low. The last factor that affects atmospheric pressure is the Earth's rotation. As the Earth rotates, the winds deviate from their original path. Now, a low pressure zone is created in the areas where the winds move out, whereas high pressure zone is created in the region where the winds move in. So therefore we see that Coriolis force caused by Earth's rotation causes the winds to deviate from their original path, and this results in the creation of high pressure and low pressure zone. So this is how Earth's rotation affects atmospheric pressure. So in today's video, we first understood the meaning of atmospheric pressure. Atmospheric pressure is the force exerted by the weight of air on the Earth's surface. Then we learnt about different factors that affects atmospheric pressure. They are temperature, humidity, altitude, and finally Earth's rotation. In our next video, we will learn how to measure atmospheric pressure. Don't forget to subscribe to our channel and hit the bell icon. You can also register for free at DeltaStep.com or download the DeltaStep app to learn one-to-one with our amazing teachers, or to get access to our 5,000 amazing videos as per your school syllabus. Master each topic with our adaptive practice technology. Get million-plus questions with step-by-step solutions and unlimited mock tests. Get all your doubt resolved instantly. Learn via games and win amazing prizes like PlayStations and iPads. So at DeltaStep, learning is not just fun and easy, but it's rewarding too. So register for free now.